This Women in Physics lesson has been shown to improve students' future physics intentions, such as majoring in physics in college or intending to pursue a physics-related career. Physics teachers who have used this lesson suggest that the optimal timing for implementation is after classroom community is established, and ideally around any time when topics of greater interest to women are being covered, such as astronomy, light and waves, biophysics, or alternative energy. This lesson has been tested in classes across the U.S. with 823 students and has been shown to increase all students' future physics intentions, with an even larger positive effect on young women than young men. In this lesson, students will reflect upon the conditions for women in physics based upon a combination of their own lived experience and data on women in physics internationally. This video is intended to give a brief overview of the lesson. For more details and access to the resources referenced in this video, please access the lesson plan packet. Students will begin this lesson with a two-part pre-assignment completed outside of class. First, students will perform an internet search to look for trends in the typical perceptions people have about physics and physicists. Second, students will read two short online biographies of both an historical and a modern female physicist. In class, students can then begin to reflect on the trends they noticed in their internet search and the biographies they read. To prepare for deeper, more personal discussion, introduce students to the guidelines for conduct during discussions. Emphasize these guidelines explicitly. Setting these norms are a critical piece of this lesson. Print and post a large-scale version of the guidelines for your students' reference. Remind students that personal conversations about gender and bias might be sometimes uncomfortable, but that it is an opportunity for learning from each other. Discomfort in a safe space is okay. Recognize, too, that it can be normal for you, the teacher, to be outside of your comfort zone when facilitating discussions with students about underrepresentation of women in physics and bias in general. Keep in mind that research shows that male and female teachers can both be equally effective at supporting young women in physics, regardless of whether you have experienced bias yourself. Many teachers find it helpful to open discussions with students by explaining why addressing underrepresentation of women in physics is important to them personally. Given that teachers and students often identify with more characteristics than their gender alone, such as race and ethnicity, be aware that these topics might come up in discussion as well. Additional suggestions for addressing these topics can be found in the lesson plan packet. Frame the discussion with the Women in Physics slides using the embedded discussion questions. As students respond to prompts, continue to refer them to the guidelines for discussion. Ask students to voluntarily contribute to the discussion on their own experiences with gender bias and how this might influence their own or others' career aspirations in physics. Using the prompt, ask students to respond anonymously on paper and toss the responses into the center of the room. Randomly pull and read responses to the class for students to comment on the experience. Do not overlook this opportunity for students to make personal connections to the content of the lesson. This is a critical component. To close the discussion, help students to focus not just on what society can do to support women in physics, but what actions each of them can take to improve the climate for women. Then, assign the Women in Physics post-assignment to synthesize their own thinking based on the lesson. Teachers find that this lesson not only informs students about the conditions of women in physics and validates some of their own personal experiences with bias, but helps to build young men's and young women's understanding about the importance of inclusion for all in physics.